Everyone, let's get started on one last thing today, composition of functions. This is going to be a really short and brief kind of introduction to how you do this. So one thing is that when we have composition, we're going to have a funky difference symbol, okay? And one of the most annoying thing about compositions is that f dot g, this is going to be multiplication. F circle G is something totally different, okay? And so one of the first things that we need to get straight is that this is a levitating open circle, and it is not a multiplication sign. Now, with that, if we write that here, just as a way to practice it, okay, that would be F open circle G. We put that in parentheses. We put the X here. As usual, don't worry about the X. Like, you need to write it there, but it doesn't really mean anything. All that X does is tell you that you have a variable of X. And because of that also, your teacher might just call this FoG because it looks like it says FoG. So you might hear your teacher say FoG or GoF if it was G first and F second, or HOG or GoF, or FoG and GoF a lot of times is how this is related or spoken about. Now, what this means, and this is really the only important thing that you're doing here. So FoG is a G of X that is inside of an F of X. Okay, and one of my strategies to doing this is I like to write the G like a little bit smaller so that it really looks like it's on the inside of the F. Simply put, composition is where instead of putting a number into a function, you're going to put an entire function into a function. Okay, and so if I was going to do a question for you really quick over here, right? And if I was going to say that F of X was 2x plus 1. If I did f of 2, that would be put the 2 into the f. So it would look like this because the 2 goes into the x, and that answer would be 5. Now what's going on here is that we're doing f of g. And I'm going to have to give you another g, which might be like, 3x. And so then this 3x has to go into that x. A lot of this has to do with, let's just make sure that we write it neatly, that we carefully put one thing into the other thing. Once we do that, easy peasy. Now we've got F, G, and H, so let's make sure we get these all correct. I've got F of G. And one thing that students will always ask, right? I will literally every single year hear many students ask is which one goes into which, right? Does this mean that F is going into G or the G needs to go into F, okay? And the answer is every time the second one goes into the first one, okay? If it's written like this, second into first. If it's written like this, second into first. Okay, so it always works like that. And I would recommend that if you're taking notes, that you write that nice and big on your notes somewhere, right? Like maybe right here, composition of functions, second one into first one. Because that is the only question you'll have, right? You'll get home for homework, you'll see one of these, you'll say, okay, I need to put one into the other, and then you'll think for 10 seconds, which one is which one's supposed to go in. So I would recommend you write that, and because of that, I also have a good habit of just doing this. Circle the second one, put the arrow. So here's my strategy for making sure that you do this correct, okay? I need F, so I need this F right here, and I need the G to go into the F. So what my strategy is that these X's are the place where the G is going to go. And so what I do is I write F of x. And then what I do is everywhere that I have this x, I'm not actually going to write this x. I might have just messed you up if you're copying along. I'm going to leave a blank anytime that I see x, right? And so instead I've got f of blank equals blank cubed plus 8, right? This is like the empty version of f. And now when I go back with g, I know exactly where g is supposed to go, right? G of x is supposed to go inside, so it should be like this, x minus 1. Now, these are going to come almost every single time with a more complicated Algebra 1 type of question to finish it, right? Because we need to make this look like a polynomial where we've got, x cubed, x squared, x, no x. We don't like this is a cubed binomial. And so these questions are going to end us up with foiling almost every time, distributing almost every time. This question is particularly annoying as our very first question because we need to do something cubed, right? So x minus 1 cubed is the same thing as x minus 1 times x minus 1 times x minus 1. We're going to have to multiply these three things together. And to start, let's just multiply two of them together, right? So I'll just multiply this one times the first times the middle, do a little FOIL. I'll leave this one alone. And so I will get x squared minus 2x plus 1. Right? Because that's minus x. That makes it negative 2. Negative 1 times negative 1 makes a positive 1. And then I've still got one of the x cubes left. Sorry, I've still got one of the x minus 1s left because it was cubed. And now I need to do another foiling. So now I need to do a triple times a double, which means take the first one times them both. X cubed minus x squared. The second one times them both. That would be negative 2x squared plus 2x. And then take the last one times them both. Plus x minus 1. Simplify this all together. These two need to combine. That would be negative 3x squared. These two need to combine. That would be positive 3x. That's not combined with anything. Should be minus 1. Now, what I've just done right here is all of this. But I've still got the 8 that has not been included in any of that yet. And so you just need to really focus on being careful, not forgetting anything, not leaving anything behind. It's just very Algebra 1 heavy, very order of operations, very PEMDAS, very combining like terms. Obviously, we need to combine these two, and we'll get positive 7. So our final answer should be x cubed minus 3x squared plus 3x plus 7. Now, this is on the harder end of questions for sure. I know this is our first one that we've done. Almost every question you do will be easier than this one. So let's just, I don't want to rush ahead and leave you guys behind, but let's just move on and see how another question works. H of G, again, second one is going into the first one every time. So I need an H, and I'm going to do my H as my template, right? So H of X, but I'm going to leave it blank, is equal to 5 blank minus 3. And then I pause for 1 second and I say, is this my empty version of H? Yes, it is. Looks good. And now I'm going to go back with my G, put it in there, and I'll be done. So that would be x minus 1 And you can tell already, this question is considerably easier than the last one because all we need to do is distribute the 5. We don't need to FOIL anything. We definitely don't need to triple FOIL anything. And so we're ready to pretty much wrap it up. H of G is 5x minus 5 minus 3. And so that would be 5x minus 8. A little bit of distributing, and we're wrapping it up. Now we're just gonna move ahead, past 13 and 14. It's more of the same. I'm not too worried about it. Going down to a question like 15, we need to also plug in a 2 here. Now these questions can be a little tricky, okay? Because what we need to do is we need to put H into G, but there's also a 2 inside the H. Now, there is a way to do this on paper, okay? You start with your G as your kind of empty version, right? Start with your G, which would be x minus 1. And then you're going to go ahead and put an H inside of that. So let's go ahead and do the H. But this H also is going to be blank because the H also has a 2 inside of the H. So that would be 5 blank minus 3. And then we're going to put the 2 inside of that. And then we just need to sort this out and we'll be done. Now, some of these questions are going to be incredibly delicate to work with, okay? What we can do is we can just do Desmos and we can just ask Desmos to do it for us, right? We can say G of x is x minus 1. H of x is 5x minus 3, I think. 5x minus 3, x minus 1. Perfect. And now we just need to do G of H of 2. Oh, 2. And the answer that we get is 6. Okay, now you need to type it in this way, where we have the G's and then the H's and the 2's, where the 2 is inside the H and the H is inside the G. The answer we got was 6. Let's double check that. 5 times 2 is 10. Minus 3 is 7. Minus 1 is 6. So Desmos is going to be way, way, way easier, right? If I was going to do number 16, I absolutely would not try to do it on paper. I would do it in Desmos. Now, Desmos doesn't even know what H or what F is, which is x cubed plus 8. So I would need to go over here. Need to make sure Desmos also knew that f of x was x cubed plus 8. And then I would need to make sure to ask it f parentheses, h parentheses, f parentheses, negative 6. Move my head out the way. H parentheses, f parentheses, negative 6. See here. H of f of negative 6. Negative 1,043, right? Crazy. Just use Desmos, right? Don't try to use, just unscratch work. There's no reason to do it. What ends up happening here is negative 6 gets plugged into x cubed, which is negative 216. You multiply that by 5. That's why it's over 1,000. Gross. F, did that wrong, sorry. H of f of negative 6. If you're worrying about how to convert the HOF to the H parentheses F, you just literally put a parentheses right here. I mean, that's all that we've done. All right, and what was it? Let's just so I have the answer here. Negative 1043. Negative 1043. Easy. That's composition of functions. There's one tiny thing I want to chat with you guys about. before we move on, okay? Sometimes we'll see a question and it'll be h of x equals 2x plus 1. I'm just making this up. F of x equals x squared plus x. And what we'll be asked to do is to find f of h. Should probably have the x there. F of h of x, okay? And that is telling us, remember, second one goes into the first. And so what we need is we need f to have an h on the inside of f, right? But what's tricky about this is that we have two different x's on the f. And so h needs to go inside of both of those x's, okay? So how this should look is x squared plus x. And then we put the h inside here and the h inside here, right? Because h is supposed to go into all the x's of f. But the common mistake that we see is that people say, oh, well, you know, f is x squared plus x. And they just leave it like this. Then they plug in the x or the h into only one of them, and you're screwed as soon as you've done this, right? This needs to be opened up for h as well. So again, how that should look is x squared plus x, and then the h goes into both of these. You would have to FOIL this one and then add this one onto it. Whatever. You guys got the idea. Just be careful if you have multiple x's that your h goes into multiple of the x's. That's it though. Composition. Just make sure that your second one goes into your first one. And if you have these number of questions, you can just type them in Desmos and it will do it for you. And it becomes much, much, much easier. All right. That's it. Composition of functions, not too bad.